All right, so in the last video, I kind of talked about how power can either be measured based on the amount consumed or the amount produced, and that depends on whether or not we're looking at a resistor, which dissipates power, or a supply or source, which supplies power to the circuit. Okay, so in our little example here, we calculated the power dissipated by the resistor, which is great, and that's often something that we're interested in finding. However, I do want to talk about real briefly. I just wanted to make this as a supplementary video because I think it's going to be useful as we move through this module. We can also basically analyze these circuits and any circuit from the perspective of either the amount of power dissipated by an element, which we did here, right? We figured out the amount of power that was dissipated by this 1 kilo ohm resistor, or we can characterize a system or a circuit by the amount of power supplied by a source, like a current source or a voltage source, or we can analyze a combination of these things. We can analyze the amount of power supplied and the amount of power dissipated. This happens to be a very particularly simple circuit. So it should be relatively obvious that the amount of power supplied by the source is equal to the amount of power dissipated by the resistor. But that won't always be the case, especially not when we get into AC circuits and AC power analysis. For this particular example, we can see that the same current flows through the voltage source as the same current that flows through the resistor, 10 milliamps here. And we can also see that the same voltage, 10 volts, is across the voltage source as it is across the resistor, right? Because they're connected, directly to one another. The voltage of the voltage source is being forced directly across this resistor. Maybe if it's not super apparent yet, it will become more apparent if I draw the circuit like this. And I just make my ground right here. Okay, and so if I were to go ahead and analyze the amount of power supplied by the source, let's just say PS instead of PR, that would be equal to 10 milliamps multiplied by 10 volts, which of course is the same as PR, my power dissipated by my resistor, and I could say that this is 100 milliwatts, which is the exact same. And so we see that power is conserved, especially in a circuit like this where we're considering no non-idealities, no parasitics. We just have an ideal voltage source connected to an ideal resistor using ideal wires. We see that the power supplied is equal to the power dissipated, and that is going to be very useful for us. The conservation of power is useful in this module. It's useful in module 4. But more than anything, I just wanted to kind of talk about this because moving forward, we're not always going to be analyzing the power dissipated by some element in our circuit. More often than not, we're going to be looking at the source itself and analyzing the amount of power supplied by our source, especially as we get into these AC circuits, because power gets a little bit more complicated than just calculating the amount of power supplied or dissipated. It turns out that as we get into these AC circuits that have impedance and frequency-dependent elements like inductors and capacitors, the power gets a little bit more complicated. We have to take into account the fact that our inductors and our capacitors, they store energy and they don't dissipate energy on average. So over n number of periodic cycles in our circuit, our capacitors and our inductors dissipate zero average power. They store energy at certain times and they release their energy at other times, and the net effect is that they dissipate an average power of 0. Okay, and so that's going to be something that we're going to need to take into account. We're going to be talking about instantaneous power in the next video, and we're going to talk about average power, and then moving through the module more, we're going to be talking about things called reactive power and real power, which is basically the same thing as the average power. And we're going to be talking about the apparent power, and it's going to start to seem a little bit overwhelming, but I'm going to do my best to explain it and try to make it make sense. And I wanted to start by doing that right here, by showing that we not only care about the power dissipated by elements in our circuit, but also about the power supplied by the source. And this is in a DC sense. Again, we're going to get into AC circuits and it's going to get a little bit more complicated. So without any further delay, I'm going to end this video, and in the next video, we'll be talking about instantaneous power.